Okay, so now we're going to solve quadratic equation, right? Ax squared plus bx plus c in its standard form, right? So this is the standard form of a quadratic equation by another method. This is called completing the square. And you can see I have the step-by-step procedure for doing that here, and it looks pretty bad, right? Um, and maybe it is, but I don't want to scare you here. It's really not that bad once you get used to it. Um, but it is a lengthy and tedious process, right? It's 8 steps. The way I have written it out, it's 8 steps. The book tends to combine some of the steps here and maybe only has 4 or 5 steps. Um, so so maybe that might seem better, but I like to break it down in each step being very simple here. Um, the problem with that is that there's more of them, right? So, so we're doing the same thing that we did in the last video, uh, right? And this is still, I think, 11.1, but you might ask the question, well, then why do I need another way to do the same thing? So, there's here's the answer, right? So the way we did this before, oops, was we had two methods so far, right? The first method was factoring. And we already learned that that method doesn't always work. If you can't factor, say by the AC method, the left side here, if this thing here turns out to be prime, right, which means it's not factorable, then you're stuck. You can't solve it that way then, right? So it doesn't always work. Doesn't always work, right? The other method that we did just last time is the square root method, which I think is, well, I hope is simple enough, right? It's not a complicated method, right? It's just basically taking square roots, right? But remember, that doesn't always work either. In particular, in order to do the square root method, remember this middle term here, this b has to be 0. Hang on, I know that looks like a 6, doesn't it? Sorry about that. This is supposed to be a b, right? So b has to be 0 for the square root method to work. And if b is not 0, then the square root method doesn't work either. So both factoring and the square root method are limited. They don't always work, right? So that's where completing the square comes in. Completing the square, as bad as it seems, this always works. What I mean by that is that it will always give you the correct solutions. Okay? Right? So completing the square works on any quadratic equation as long as you can write it in standard form. It will always tell you the solutions. Now, remember, the solutions might be imaginary numbers. They might be irrational numbers like the square root of 2, but it will still give you the answer. It will still tell you the answer in every case, right? So that's the nice thing about completing the square is you don't have to worry about, oh, maybe it's not factorable, right? Maybe this is not factorable, or b might not be 0, and then the square root method doesn't work. Right, so yeah, the factoring and the square root method, as I mentioned, don't always work. When they do work, though, they're pretty simple, right? And I think you're used to factoring by now, at least I hope you are. And you might be still getting used to the square root method, but once you're used to that, it works pretty simply, right? It's not that bad. Right. So now we're going to do a problem, well, that doesn't work by factoring or the square root method. And we're going to use the square root method. I'm sorry, the completing the square method. Right. So here's the example. Example 1, at least for this video. So here we want to solve, and I'll write the equation in standard form. This is going to be x squared minus 6x plus 4 equals 0. Okay, so this is in standard form, and you can check, right? A is 1. We don't usually write the 1, but write A is 1. b is negative 6, and c is 4. Okay, so this is in standard form already, and it equals 0, right? You have to have 0 on the right here, right? So before we get to completing the square, let's just sorry. There it is, right? Okay, so let's see if we can factor this, right? Can we factor the left side? Right, so it's just x squared minus 6x plus 4. So plus 4, right? So can I find two numbers that multiply to 4 and add to negative 6? So to add to a negative, right, and multiply to a positive, both numbers need to be negative, right? So let's try negative 2 times negative 2, which is negative 4. Well, that would, when you multiply this out, you get negative 2x minus 2x, you get negative 4x plus 4. So the plus 4 is correct, right? But what's not right is the middle term, right? This should be negative 6, not negative 4, so that did not work, right? Well, let's try the only other thing I can think of is negative 1 times negative 4 is positive 4. And when you multiply that out, you get x squared minus 5x plus 4. So again, the plus 4 is fine, but we're looking for negative 6, not negative 5. Right? Yeah, I know they're close, but they're not a perfect match, right? So that doesn't work either. And you can try, you can try x plus 1, x plus 4, but then that would add to a positive 6. So it turns out that this just doesn't work, right? This is prime. It's not factorable over the integers, right? Or even over the rational numbers. So you can look for fractions, you can look for, imaginary numbers. It's not going to work, right? So yeah, factoring doesn't work. And the square root method doesn't work because b is negative 6, right? b is not 0. So the square root method doesn't work either. Right. So this is why we need completing the square, right? Because that's the only thing that will work in this particular case here. Well, okay, later on we'll learn a fourth method, right? So this is our third method here is completing the square, which always works. And there is another way to do this, but that will come in the next section. So until we get to that, let's just use completing the square here, right? Okay. Okay, so let's just go step by step here, right? The first step is to write the equation in standard form. Well, I think I already mentioned this is in ax squared plus bx plus c equals 0. I erased the a, b, and c because in this case we don't need them here, right? So it's already in standard form. So step 1 was done for us, right? If it's not, let's say it's x squared equals 6x minus 4, right? Then you have to subtract the 6x and add the 4 to both sides, right, to put it in standard form. But in this case, that was done for us, right? Okay, right? So yeah, at this point, this is already in standard form. X squared minus 6x plus 4 equals 0. And step 2, as you can see up here, is to divide both sides by a if a is not equal to 1. Well, remember, a does equal 1 here. So step 2 would be to divide both sides by 1. But that's kind of silly because, well, dividing by 1 or multiplying by 1 doesn't change anything, right? 5 divided by 1 is still 5, right? 0 divided by 1 is still 0. So when you divide by 1, you're really not doing anything new here. So because a is 1, you don't have to divide by it. Or if you do divide by 1, well, you end up with the exact same equation, right? So you don't get anything new by dividing by 1. Right? However, if this were a 3 in front, if a was 3, then yes, then you have to divide both sides by 3. Okay? In other words, the coefficient of x squared has to be a 1. Right? And if it already is a 1, then great, leave it alone. So step 2 was essentially done for us as well. Right? Okay, again, and not in every problem will it be this simple, but we're starting with a relatively simple one, right? So let's go on to step 3 here. I'm trying to write the number 3 as my step 3. Yep. So, okay, this is the first non-trivial step. We have to subtract, right? We want to subtract the constant from both sides of the equation, leaving only the variables on the left side, right? So what do I mean by the constant here? The constant is just this number here, the 4, the thing without the x, right? Without x squared, without the x, it's just 4. So in step 3, then, yep, we want to subtract 4 from both sides. And by the way, if this were a negative 4, we would have to subtract a negative. In other words, we would add 4 to both sides. So when I say subtract, I really mean do the opposite of, right? If we're adding 4, the opposite of adding is subtracting 4. If this were a minus 4, then you would have to add 4 to both sides, right? Okay, so, all right, so step 3, you still have x squared on the left, the minus 6x on the right, and, I'm sorry, on the left, negative 6x, and then on the right, you have 0 minus 4, which is now negative 4. Okay. Yeah, so notice that at this stage here, after step 3, it's not in standard form anymore, right? So this is no longer in standard form, but that's okay. Right, so to do completing the square, we don't want it in standard form. And the same thing was true, by the way, with the square root method. Right? You had to subtract the c from both sides, right? You have to isolate the x squared. Right? And that's kind of what we're doing here, but it's obviously it's going to be a little more complicated, right? So let's go on to step 4. And so here's step 4 now, which says to take the coefficient of x, divide it by 2, and then square the results. So what's the coefficient of x, right? So here's the x. The coefficient is the number in front. That's the negative 6, right? So what do we do with the negative 6? So this is step 4 over here now. You take the negative 6 and you do two things. First, you divide it by 2. Okay, not hard. Negative 6 divided by 2 is negative 3. And then you square the results, right? So after you divide by 2, you square it. And when you square negative 3 times negative 3 is positive 9, right? It's a negative times a negative. So after you square the result, after you square that number, you should always get a positive number here, right? In this case, positive 9. Make sense? Okay, so that's my step 4. Step 5 says to do the following. Take the number that we just got, right, which is the negative 9, the positive 9 here. Yep, it's not negative, it's positive, and we're going to add that number 9 to both sides. Okay, so we're going to add 9 to the left side, and we're going to add 9 to the right side. And again, if you're worried about that, you could put the 9 over here as well. In this case, it doesn't matter. Negative 4 plus 9 or 9 minus 4 is the same thing. Okay, so what do we get now? On the left side, we get x squared minus 6x plus 9. And on the right side, we get negative 4 plus 9, which is 5. Right, just positive 5, right? Okay. Okay, so that brings us to step 6. Step 6 says to simplify the left side. I'm sorry, well, simplify the right side. We did that already, right? The negative 4 plus 9 is 5. Okay, so that's part of step 6. The other part is to factor the left side, that's this side, as a perfect square trinomial. So this might be a good time to remind you, what is a perfect square trinomial? So this was way back in chapter 6 where we talked about factoring, and it's basically this. You have a squared plus 2ab plus b squared that factors as a plus b quantity squared. The other form is if you have a squared minus 2ab plus b squared. That factors as a minus b squared. And in fact, this is the one we're going to use here. So my a being x and my b being 3, right? So yeah, so a is x, right? And b is 3, square root of 9 is 3, right? Then we can factor this left side as x minus 3 quantity squared. Right? Now, it's true, you didn't have to you didn't have to use a perfect square, rather. You could have just factored this as x minus 3 times x minus 3, just using the AC method, right? And that's perfectly fine, but then after you do that, you should write it as a perfect square. X minus 3 times x minus 3 is x minus 3 quantity squared, right? So that's step 6, and the right side is still 5, right? Okay, well, notice we're almost done here. The next step is to, well, if you notice, the whole point for doing this at this point is this was the type of problem that we did in the last video, right? We're solving for x here, and we want to get rid of the power of 2, the square. So how do you undo the square? Yep, square root method, right? So at this point, you're just going to take the square root of the left side, right, to get rid of the square here, and then don't forget the square root of the right side, right? This is not negative, so there's no imaginary numbers here. But also don't forget the plus or minus. In fact, I remind you of that right here. Don't forget the plus or minus symbol. Very important. Right. And so what you get at this point, and I know I'm running out of space again, is you get x minus 3 on the left, right? Because this square root cancels this square here, right? So you just end up with x minus 3, and that's going to equal plus or minus, right, the square root of 5. And the square root of 5 is the square root of 5. It's a prime number. It doesn't contain any perfect squares, so right, this is already simplified. There's no reason to try to go any further here. But if you could simplify, like if it's the square root of, I don't know, 16, then you would write it as 4. You know, if it was the square root of 8, you would write it as 2 square root of 2, and so on. Right? So you do want to simplify that eventually, right? So step 8, solve for x. Yep, the only thing left to do now is, of course, add the 3 to both sides. Right? So yep, that's your step 8. So negative 3 plus 3 is 0, so you just get x plus 0 equals 3 plus or minus the square root of 5. And we're done. Those are the two solutions, right? There are two of them. Let me write them separately, right? There's x equals 3 plus the square root of 5. And the other solution is x equals 3 minus the square root of 5. Sorry, that's a 5. Okay? So that's it. That solves this equation way up here, right? That was the original problem we wanted to solve. And now we have our solutions, right? And in fact, these are rational numbers. They're not imaginary, right? So you can plug these in a calculator and approximate them. So let me do that for you now. Or I would encourage you to try this on your calculator, see what you get. So you should get, for the positive, 3 plus the square root of 5 is about 5.236, so I'll round to 3 decimal places. And then 3 minus the square root of 5 is about 0.764, I think. So remember, these are the approximations. These are approximates. Approximate. And then these over here, these are the exact solutions. Okay. And for the most part, we're only going to ask for the exact solutions, right? I'm not going to ask for the approximate. you know, if they ask that on Connect Math, well, then just use your calculator and put in the approximate. But I'm more worried about the exact answers. So that's it. That's completing the square, and I know like I say, it takes a lot of getting used to. This is not a simple procedure here. It's 8 steps, right? Just broken into step by step here, right? So so obviously we'll do another one, and you know, hopefully you'll get more used to this. But you know, it's like I say, it always works, and you can see why factoring did not work here. When you factor, you're not looking for 3 plus the square root of 5, right? You're looking for 3 or negative 3 or 5 or negative 5, right? You're not looking for square roots when you factor, right? It's kind of pointless to do that because then you could be looking forever here, right? But you can see that's why the factoring, we tried it here. We tried it, and it just didn't work, right? It ended up being prime, and so factoring just did not work. Which is why we need completing the square in this case, right? And that was the only way to do this, at least up till now. Okay, so let's go on and do a second example here. Okay, we're going to solve by completing the square. X squared plus 10x plus 9 equals 0. So, yeah, so step 1, well, if you have to look it up here, write in standard form. So notice this, just like the last problem, is already in standard form. So there's really nothing to do here. You just rewrite it. X squared plus 10x plus 9 equals 0. Step 2, divide by a. A is 1. So there's really nothing we have to do here either. And in most of the problems we give you, a is already going to be 1. If it's not, it could be a much more complicated problem. And maybe we'll do one of those, but I don't see that coming up in the homework or on a test, obviously. Okay, so step 3, remember step 3 is to subtract the constant from both sides. It's a positive 9. The opposite of adding 9 is subtracting 9. So when you subtract 9 from both sides, you end up with x squared plus 10x equals negative 9. Okay. Step 4. Actually, step 4 I'm going to do over here because this is my scratch work here, right? Step 4 is to take the number in front of the x, that's the 10, right? And, well, I didn't want to mess that up here. So yeah, the number in front of the x, the coefficient of x is 10. And we got to do 2 things to it. First, just cut it in half, right? Divide it by 2. And then square it. So 5 squared, 5 times 5 is 25. Okay, what do we do with that number? Well, in step 5, we have to add that to both sides. So here's what we have from step 3. Now in step 5, we're going to take the 25, add it to the left side, and add it to the right side. Okay, so we're up to step 6, right? So for the left side, well, for now, let's leave that alone. But on the right side, we can do negative 9 plus 25, or 25 minus 9 is 16. But the key to step 6 is right, obviously we have to do that too, right? So simplify 25 minus 9. But the key is to factor the left side. And you're supposed to factor it as a perfect square. But I think you'll see here there's 2 options. It's either 5 times 5 is 25, right? And 5 plus 5 is 10, or it's 1 times 25. But 1 plus 25 is 26, not 10. So that didn't work, right? So yes, it's just going to be x plus 5 times x plus 5. In other words, these had to be the same, right? It has to be a perfect square trinomial, which means you want to write it as x plus 5 the quantity squared, right, equals 16. So it's still equal to 16. Okay, so yeah, step 6 is always factoring. And if you do it right, it should always factor as, a plus b squared. Well, let me remind you, once again, if you have a squared plus 2ab plus b squared, and that's exactly what we have on the left, right, then you can rewrite that as a plus b quantity squared. So that's the factored version of it, right? Yeah. And in the last problem, this was a minus, so then that became a minus. So there's your plus or minus as well. So yeah, I wrote it both ways last time here. But if you're clever, you can write it all at once using a plus or minus symbol. All right, on to step 7. So you remember what step 7 is? Yeah, just get rid of the square, right? We want to undo the square, so take the square root. Right? So the square root cancels the square. And on the right, you get, don't forget the plus or minus, square root of 16. So the left side is just x plus 5, right? And the right side is plus or minus, well, the square root of 16, I hope you know that's just 4, right? Yep, in the last problem, this did not simplify. It was the square root of 5, so you have to leave it. But the square root of 16, yeah, don't leave it as the square root of 16, right? Simplify it to get 4, right? Or plus or minus 4. Right? Right, and then step 8, just take away the 5 from both sides, subtract 5 from the left, and subtract 5 on the right. So I'm going to squeeze that in here. And yep, 5 minus 5 is 0, so x equals negative 5 plus or minus 4. Okay. Now, you can't leave it like that, right? Please don't leave it like this, because there are really just two numbers here, right? One of them is negative 5 plus 4, and the other is negative 5 minus 4. Split them up and do them separately. Right? Negative 5 plus 4 is negative 1, so there's one answer. And negative 5 minus 4 is negative 9. So there's another answer, right? Two answers. And they did work out to nice numbers here, right? So that's why you can't, you can't leave it like this here, right? Because the two numbers are just negative 1 and negative 9. So write them separately, right? Why didn't we have to do that here? Why did I say in this problem that you can leave it like this? Well, because these are two different numbers, right? The 3 is a rational number, the square root of 5 is irrational, and they don't mix. They just don't mix, right? So yeah, even if you split them up, you have to leave it as 3 plus the square root of 5 and 3 minus the square root of 5. You can't simplify that any further. You can approximate it. You can get the decimals like we did here, but there's no way to simplify these here, right? Unlike in this problem, you can simplify negative 5 plus 4, right? Which is just negative 1. And you can simplify negative 5 minus 4, right? which is negative 9. And so, yeah, so make sure you do that, right? In any event, so what happened here, what happened here is that we could have done this problem by just factoring. And in fact, let's do it now, right? So remember, we wanted to solve x squared plus 10x plus 9 equals 0. So what two numbers, these are x's here, right? What two numbers multiply to 9 and add to 10? Well, there's only two ways of doing this, right? 3 times 3 is 9, but 3 plus 3 is 6, not 10. So what about just 1 times 9? 1 times 9 is 9, and 1 plus 9 is 10. So that works. And now you just set them equal to 0. And when you subtract 1 from both sides, you get x equals -1, and then you get x equals -9. See how easy that was, right? That's factoring. That's doing this by factoring. So why didn't we do it that way? Because that would have been so much easier than doing all 8 steps here. So the reason why we didn't do it that way is look at the directions. They didn't give us a choice. They said we had to complete the square. We had to do it this way, right? As unpleasant as that was, they want us to get used to completing the square. So even though this was doable by factoring, oops, sorry, I didn't mean to do that. This was doable by factoring here. Yeah, we were supposed to complete the square, and we did. So yeah, obviously this was not the way I would have preferred to do it. You probably would have preferred to do it by factoring down here on the right. But yep, the directions did not give us the choice. Now, if the directions say solve by completing the square, and you do it this way, you do it by factoring, well, then don't expect to get full credit. You're going to lose points for not following the directions. The directions say complete the square, you got to complete the square. Like it or not, you just have to do it that way, right? You know, and I'm pretty generous, right, with partial credit. You will get partial credit if you do it this way, and you do it correctly. If you get them right, you know, you'll get some partial credit for at least doing it correctly. But you will lose substantial credit for not following the directions. They really wanted you to complete the square here, even though this was doable by factoring. Right. And in fact, in the first example here, we didn't have a choice. We tried factoring and it didn't work, right? Did not work. So we didn't have a choice. We had to complete the square to solve this problem up here. Okay. So in problem 2, we did have a choice, although they forced our hand by giving us the directions that we had to use completing the square. So that's how that works, right? We had to complete the square. And yes, we ended up with nice numbers. And that typically means that we could have done this by factoring if we wanted, right? But yeah, that's completing the square. So I hope that helps. I guess we'll do one more. So I don't think I have enough space. Oh, maybe I do. Well, okay, so just in case, I'm going to clear everything and we'll start over. Okay, so, yep, so example 3, we want to solve by completing the square. Again, let's follow the directions, right? And so let's go back to step 1. Step 1 is to write it in standard form. And in this example, they don't give it to us in standard form, right? Because it doesn't equal 0. So what do we need to do? We need to add the 3x to both sides. And then we get x squared plus 3x equals 14. And, well, okay, so now we're supposed to subtract the 14 from both sides as well to put it in standard form. Although you'll see later that we're just going to undo that in just a minute, right? So here it is in standard form. X squared plus 3x minus 14 equals 0. Okay, so A is 1, right? B is 3, and C is negative 14, right? And because A is 1, sorry, because we don't need those here. Step 2 is to divide both sides by 1. And remember, when you divide by 1, you don't get anything different. So, yep, again, will A always be 1? Of course not, but in the homework problems and the ones that you're going to do by completing the square, yeah, they will be. They will be. And if there is, maybe we'll do one more where it isn't, but that's making it probably too difficult, right? So this already is going to be bad enough, as we'll see, right? So remember what step 3 is. It's to add the 14 to both sides, right? Well, subtract the constant. So you're subtracting a negative 14, but you know, a negative of a negative is just positive. So the opposite of subtracting 14 is adding 14. So let's add 14 to both sides. So we still have x squared plus 3x on the left, and then we have 14 on the right. And if you notice that we actually got that here. And let me remind you, we had x squared plus 3x equals 14, right? But to put it in standard form, we had to subtract the 14, and then it turns out we're just going to undo that later anyways. So we could have left it like this, and that would have been step 3 already. But you know, I'm going the directions that they say to go in. So we had to subtract the 14 and then add the 14 back again. Sorry about that, but that's, you know, that's going step by step here, right? So step 4, remember step 4 should be done separately over here. You take the number in front of the x, right? That's the 3 here, positive 3. And we got to do 2 things. We cut it in half, divide by 2. Well, you get 1.5, but I would not write it as a decimal. Leave it as 3 over 2, right? So you divide by 2, and then you square it. So remember, you can square the numerator and the denominator separately, and you end up with 9 over 4. Yep, sometimes you get fractions, right? And that's because the 3 is an odd number. Up until now, I think we had 6 and 10. 6 and 10 were both even numbers, and so when you divide by 2, you get a whole number. But not in this case, right? In this case, we have 9 over 4 as the answer to step 4. So what's step 5? Step 5 is to add that number to both sides. Okay. So, yep, on the left side, we're going to add 9 over 4. And on the right side, we're going to add 9 over 4. Okay. So those are fractions. Sometimes you just have to deal with fractions, like it or not. So what do we do in step 6? Well, in step 6, we simplify the right side, right? And this is 14 over 1. Well, I think we need a common denominator here, which I hope you recognize is the 4. So for the first fraction, we're going to need to multiply the denominator by 4. Right. Multiply, right? And that means we have to multiply the numerator by 4 as well. Right. So what do we get? We get 14 times 4. Oops, I didn't want to use green again. So 14 times 4, I think 56, right, over 4, plus 9 over 4, and that's going to be 65 over 4. I think that's right. Hang on. Yeah, I think that's it, right? So let's just rewrite this. Right, so the left side is still x squared plus 3x plus 9 over 4. And the right side is just 65 over 4. Okay, so step 7. What was step 7? Step 7, oh, actually we didn't finish step 6 yet. Sorry about that. Step 6 is to factor the left side here. And so how do we factor this? Yeah, so we should factor x squared plus 3x plus 9 over 4. And you might be thinking, you have to be kidding me, right? I mean, we know how to factor things like x squared plus 3x plus 2, right? But up until now, I don't think we've had to factor things with fractions like 9 over 4, or even 1/2, right? And that's probably true. You probably haven't seen this as a factoring problem. Or if you did, then it was a pretty difficult one, right? However, remember that this should always be a perfect square trinomial, which means this is going to factor as a plus b squared. My a is just x. And what's my b here? That might not be clear, but it has to be the square root of 9 over 4, right? And if you go back and take the square root of 9 over 4, you just get 3 over 2. Right? So b is 3 over 2. And that means this is going to factor as x plus 3 over 2 squared. Okay, so yeah, in this case, it was very helpful to know the perfect square trinomial combination here, because otherwise, yeah, this is a very difficult factoring problem. But it does factor as x plus 3 over 2 squared. And you can check, if you multiply this out, you do get this, right? So yeah, factoring problems with fractions, obviously not something we've done before, but if you think of this as a perfect square trinomial, it works out perfectly here. Okay, now we can go on to step 7, right? Step 7 is to get rid of the square, so we just take the square root, and that undoes the square. Takes out the power of 2 here, right? Okay, right, and do the same thing on the right. Don't forget the plus or minus. All over 4, right? And so on the left side, right, remember the square root cancels the square, so you just end up with x, sorry, it should be an x plus 3 over 2. And what do we get on the right side? So remember, we can split this up because it's a quotient. We can take the square root of 65 in the numerator and then the square root of 4 in the denominator. Well, the square root of 4 is just 2, right? So this is the square root of 65, I got to squeeze it in there, divided by 2. And I'm going to move this over just a little bit. Plus or minus, right, the square root of 65 all over 2. And what about the 65? Can we simplify that? So 65 is not divisible by 2 or 3 or 4. But if you divide by 5, you get 13. And 13 is a prime number, 5 is a prime number, so that's it. It's just 5 times 13. Neither one of these are perfect squares, so no, we cannot simplify this any further. Again, you should try, but in this case, we don't get 4 or 9 or 16. We don't get the perfect squares, right? Okay, so yep, we can leave this as it is here, square root of 65 over 2, right? And then step 8, well, just take away the 3 over 2 from both sides. So subtract 3 over 2. Subtract 3 over 2, although I think we want to put the negative 3 over 2 on this side here. Okay, so yep, we're almost done because we have x on the left, x equals, right, because this adds up to 0 by design. And on the right, we have negative 3 over 2 plus or minus the square root of 65 over 2. And there's really only one thing left to do. Notice that these two fractions have a common denominator. So that means you can add, or in this case, add and subtract, right, the numerators. So we get negative 3 plus or minus the square root of 65 all over 2. And those are our solutions, right? Those are our solutions. If you write them separately, that's okay too. You get negative 3 plus the square root of 65 all over 2. And then for the negative, you get negative 3 minus the square root of 65 all over 2. And you don't have to approximate, but, oops, sorry, didn't mean to do that. Right, so again, these are just written separately. And if you want the approximate, just use your calculators. Okay, so there's the approximate that the calculator gave me. So for the positive square root, we got 2.531. And for the negative square root, we got negative 5.531. Like I said, I wouldn't worry about the approximate. We're looking for these. We're looking for the exact. And again, you can write it all together like this, or you can split them up like this. Either way is fine. Right, and right, if you remember in the last problem, we didn't get, negative 9 and negative 1, so So these numbers here are, you have to leave them as they are. These are as simple as it gets, right? In other words, these are simplified here. These are simplified. But if you can't simplify, like, if this were the square root of 8, or, the square root of 24, right? Those you can simplify a little further, but not 65. We tried. We did that here, and we got the 13 and the 5, and that just doesn't work out. So, okay, so that's completing the square. And this was a little bit harder because, again, you get fractions, but in some cases fractions are unavoidable. And in particular, factoring with fractions like this can be a little bit of a nuisance, but you got to remember it's always a perfect square trinomial in step 6 here. So this factoring will always be done as a perfect square trinomial like this. It could be, a plus b or a minus b. In this case, it's a plus because that's a plus. But yeah, in some problems, it'll be a minus as well. Anyways, that's completing the square. I don't see the need to do another one unless you really want to. I think these 3 examples are pretty good. And so maybe I'll just recap what you do here, right? So when you're completing the square, right, first step is standard form, right? In many cases, it'll already be in standard form. In this problem here, it wasn't quite in standard form, but that's just getting everything on the left, getting 0 on the right. Right, and step 2 is just dividing by the leading coefficient, which if it's 1, don't bother. And step 3 is to get the constant to the other side. In this case, the opposite of subtracting 14 is adding 14 to both sides. So you bring the constant to the right side like we did here. That's the 14. And in step 4, you have to calculate this number here. What number are we adding to both sides? Well, we take the number in front of the x, that's the 3, cut it in half like we did here, then square it, right, like we did here. And yep, in this case we get a fraction, right? We got 9 over 4, and that's the number we added to both sides. Okay, so that's step 5. Step 6 is to factor it's to simplify the right side, right? So this we simplified as, right, 65 over 4. And on the left side, you're going to factor this as a perfect square trinomial. Again, that was a little bit of a hassle because of the fraction 9 over 4. You're not used to factoring when you have fractions like that. But just let it be known that it can be done. You just have to remember this formula, the perfect square trinomials, right? Okay, just cleaning all that up, I think. All right, so that's step 6. Step 7 is to just get rid of the exponent of 2, right? Take the square root of both sides, right? So when you take the square root of both sides, that gets rid of the power of 2, right? And I messed this up already, but we had x plus 3 halves. So step 8 is just to subtract that number from both sides. The positive 3 halves, subtract 3 halves. And then, in step 8, in some cases, you might have to simplify this. Right, so don't forget to simplify if necessary. In this problem, it wasn't necessary. This is as good as it gets here, right? So that's your final answer. All right, so I know completing the square, kind of a horrendous process here, but you should get used to it. To be fair, there's usually one question on the final that asks you to complete the square, right? And on the next test, test 4, there will be at least one question where you have to complete the square. I would say 1, no more than 2, right? So even doing this once is kind of bad. So probably just once, possibly twice, but no more than that. So that's completing the square.